Rubik's Cube is actually a geometric figure called a hexahedron or a cube. See, it's a 3D shape. So today we are going to learn what makes a figure a Platonic solid and why there are only 5 different possible kinds that can be made. So first, we're going to start with reviewing our concepts that we went over last week. Okay, so first, faces. Any of the individual surfaces of a solid object. So the faces of the Rubik's Cube are going to be right here, here, back here. All right, vertices, a point where 2 or more straight lines meet, so a corner. So if you flip over it, this is going to be a vertex right here, or a vertice. Vertex is going to be right here and all over the cube. And the last one, edges, the line where 2 surfaces meet. So on this Rubik's Cube, it's going to be this line right here. This is also an edge right here. And this is also an edge. So now that we've started by reviewing our concepts, we're going to talk about why the Platonic, we're going to talk more about Platonic solids. So let's cover why there are only 5 Platonic solids. When we add up the internal angles that meet at a vertex, it must be less than 360 degrees. I know that's kind of a handful right now to figure out, so let's work through this together. So, what it's saying is that the angles at the vertex are less than 360 degrees. So, to make a Platonic solid, these 3 faces right here are going to meet with this one vertex, and all of their internal angles have to be less than 360 degrees. So, let's look at the first one, the one that we've been working with, which is going to be the cube. So, we know that a square has internal angles. Internal angles are 90 degrees. So, to be a Platonic solid, 3 faces have to meet at a vertex. So we're going to have 90 degrees for one face, plus 90 degrees for the next, plus another 90 degrees, which is going to equal 270 degrees. 270 degrees is less than 360, so this is why this works for a Platonic solid. Let's look at the other ones. So first, let's see. Now that we have the cube, so let's look at the next one on the list. When 3 pentagons meet, it makes a dodecahedron. Let's try to say that 3 times fast. So let's look at this one. So a regular pentagon has internal angles of 108 degrees. So 3 pentagons meeting would be 108 plus 108 plus 108, which is going to equal 324, which is also less than 360 degrees. All right, so let's look at when 3 triangles meet, makes a dodecahedron. So we know that our internal angles, we're just going to say for right now, is going to be IA, internal angle, is going to be, which one are we looking at? The triangles. So we know that the internal angle is 60 degrees. So, you go down here, 3 faces, or 3 internal angles meeting up, 60 degrees in each is going to come to, actually, it's going to be 180. There we go. All right. And you can also have, this is the fun thing with triangles. So triangles, this is when 3 of them meet. But we can also have when 4 triangles meet and when 5 triangles meet. So just to make sure, so let's look. This is the 3 triangles meeting. Let's go down and do 4 triangles meeting. So this should just be the internal angles, except you're going to have 4 internal angles. So this is going to be 240. And you can even have 5 internal angles, which is going to be 60 plus 60. Equals 300. So with the triangles, all of these are less than 360 degrees. So that's how we know that these can make up a Platonic solid. So now we've checked off these three, and they all have angles at vertex less than 360 degrees. That's why they make the Platonic solids. So today, for our wrap up, we are going to gather into groups of 5. Each of you is going to come up with the definition of a Platonic solid and answer the question of why there can only be 5 Platonic solids in your own words. Now each group is going to create a poster. I'm going to give you guys poster paper. I want you to illustrate them with the 5 different Platonic solids and their names. Again, why there's only 5 Platonic solids, and a definition. After you guys are all done illustrating them, we're going to hang them on the edges of the wall so that we can decorate the walls. All right, class, let's get started.